What's up, pretty people? This is Bins, signing in for a new episode in the Shapez BEASTMAM series. Excuse me, could you do the thing with the whoosh? You know, the whip thing? Thanks. We've arrived at episode 3 in the subchapter that's all about calculating the remainder. The first episode elaborated on the theory of how to build a subtraction module, and in episode 2, I talked to you about how to provide the filter input for it, simultaneously taking advantage of the opportunity to perform all of the combining that may be needed, without even having to worry about whether it's necessary or not, so be sure to check that out if you haven't seen it. Today, we will look at how the subtraction module works in practice, and I've got a bit of a confession to make. I did a stupid. While 2 episodes ago, I went into detail about how to build a subtraction module, I wasn't paying attention to the fact that in the actual machine, I've built a totally different kind. The setup I decided to go for in the end is different from the model we built together 2 episodes ago, so that was kind of dumb. My apologies. At the very least, we now know that there are different approaches to this kind of subtraction module, and today we will have a look at the one that is actually in the factory. Now, the last one we did, that was this one. And the difference between the two is that for our example module, this one, I use virtual shape cutters for both types of inputs. Whereas in the setup I decided to go with in the end, the side input or filter input, in this case, in this layout, it's coming from the bottom. That one is determined with analyzers instead of cutters. So here, the idea is that we are always going to work in the top right corner of the shape, and we rotate the input so that the thing we want to analyze becomes the top right corner of the shape. All right. So here, the main input line is the blue one. It comes from the right and it moves left. And the signal is going to encounter a fork in the road where it will take either the top path with the nipper on it or the bottom route that doesn't. Then the signal is rotated, both paths join, and then this repeats for all 4 quadrants. Now, the decision of whether the shape is sent through the nipper or not, that will depend on the bottom input. If a quadrant exists in that corner of the shape we want to subtract from the main one, then we will get a signal from the bottom, which will close the bottom route and open up the top route with the nipper on it. And otherwise, the top right quadrant won't get nipped, so to speak, and we just rotate the shape. And after 4 rotations, we are back to our starting orientation, and the signal gets sent to the output line at the top. So let's demonstrate that. I've prepared a shape right here. And if I connect that one, right, then it will simply be output. And if, for example, I connect a top right quadrant to that, then you see that the following will happen. So this shape will travel through the analyzer units. In this case, it's only the left one that will get used. And then after passing through these diodes, which serve, you know, the tick precision purposes, you will see that this NOT gate right here will cause this line to trigger, or to be shut off rather, and instead the signal that passes through the nipper will be used, right? So the top right quadrant is nipped away, it's cut out, and the result will be that, you know, the remainder, the other 3 quadrants remain from this shape. So let's demonstrate simultaneously that this is also a tick synchronized module. So let's put this in, advance 1 tick, and then take this shape with 2 quadrants here, advance 1 tick, take this one with 3 quadrants, advance 1 tick, and then finally take the one with 4 quadrants, advance 1 tick. So you will see that all of these things, they just neatly travel through, and with tick precision, they will make it through these modules. So out the other end comes, firstly, the bit with the remainder with 3 quadrants, then the remainder with 2 quadrants, then the remainder with 1 quadrant, and finally, nothing, right? That is how that works. Same approach basically as the other one, except instead of working with cutters here, we work with analyzers for the filter input and then the nipper for the main input, all right? So now let's look at where and how that fits in the main module, all right? If you've seen the previous episodes, then you will know that we get 10 inputs coming from the left, right here. Of these 10, 5 are the actual floating pieces that come from the clock. And the other 5 are code shapes that determine where those floating pieces go. Then in this module right here, we convert them into the module's side input with this entire combiner setup that we talked about last time. Now in the meantime, I run another signal, which is the main shape signal. I run a copy of that through another unstacker module with lane correction, and that way we get the actual shapes 4 layers output right here. And that means that in total we now get 8 wires. 7 of them are here, and then the 8th one is like sneakily stuck in here. Those are, well, the 4 layers of the main input on one hand, and then the 4 wires that come from the remainder. And the layers of the actual shape, those will be the main inputs, and the ones that come from our combiner modules, those will be the side inputs. Those will be the ones that we will subtract from the main inputs, all right? So per layer, all of these lines go in. We have the main input here. No, sorry, we have the main input here. We have the side input here. So in this case, we see a yellow quadrant and a white one. From that, we are going to subtract the white one, and out comes the remainder, the yellow one, right? We do this for all of the 4 layers. All those lines go in, the subtractors do their thing, and out the other end come the remainders. Now, at this point in the algorithm, we have actually gathered all the ingredients we need except for one, and that's the 5th layer. If you don't know about 5th layer stacking, it comes down to the fact that in some occasions you require 5 layers of input in order to create a 4-layer shape. In this video, I won't elaborate on the reasons why, nor the occasions where you may need a 5th layer. So if you'd like to know this, then you consider watching my BEASTMAM series about building a TMAM in the vanilla shapes game, because I do a lot more explaining there. For this video, I will simply assume that you know about the 5th layer, all right? Anyway, the final ingredient of our cocktail is actually very easy to obtain. The only thing you need to worry about is whether the shape has 4 layers or fewer. If it has 4, you can always stack a 5th layer without giving it any thought. It will always work out. Whether it's actually required or not, it will always work. If the shape has fewer than 4 layers, then you don't add the 5th layer. It's as simple as that. And so the only thing you need to do is create a little module like this. So you've got your main input, right? And then we are going to put unstackers on top of that. 1, 2, 3, 4. Let's take, come on, thank you. Let's take a 4-layer shape, any random one, like this one, for example. Let's connect that up. There we go. And the only thing we actually need to do is determine whether we have an output right here, right? because if we do, then the shape is going to have 4 layers. And if it has 4 layers, well, then we can mindlessly add the 5th layer on top, right? Like so. That's how that works. And if we have a shape with fewer than 4 layers, for example, this one, then we don't get the 5th layer. It's really as simple as that. Okay, so how did I do that? Well, I condensed that principle a little bit, so that's what we get right here. And if we if the main shape, this is the main shape, it's switched meanwhile, if it has 4 layers, then we are going to add this 5th layer thing. Now, this is just a bit of a bizarre signal. We will still get back to where this signal comes from. It doesn't have to be 1 layer, it can be any amount of layer as long as it occupies all 4 quadrants, right? So in case we are dealing with a shape that has 4 layers, then we get this signal added to the mix, and that will give us a total of 8 lines. We have the 4 remainder pieces that come from our subtraction module. Now we have the 5th layer, so that makes 5 lines, and then I am also going to bring in the 3 combined pieces that we got from our combination module right here. So all of the combinations of floating pieces that have their base layer on layer 1, combination of pieces on layer 2, and combination of pieces of floating pieces with base layer 3. I'm going to bring those in as well. And with those 3 plus the other 5, that's how we end up with 8 wires, and those are the final 8 values that we can run into our next module. And that concludes all of the preparations we needed to make in order to supply the next module in line. And that module will be the validation module. In other words, the one that tells us whether the machine has found a solution or not. And if you want to figure out how that works, well, then I guess you're just going to have to be patient for the next video. Psst, subscribe to the channel. If you don't want to miss out, click that button. Anyway, with the subtraction module covered, and therefore the calculation of the remainder under our belts, not only can we conclude the 3-part subchapter about the remainder, but we've also unveiled yet another component of the BEASTMAM's decoder. So I sincerely hope that you've been enjoying the way in which the different bits and pieces we've discussed about this machine have been coming together and are slowly falling into place. Because if you have, then I am 100% positive that you will also enjoy the upcoming videos in this series. Well, it would be a stretch to say that we've only scratched the surface, because we've explored more than that. There is definitely a lot of interesting stuff left to discover about this machine. Trust me, we're not even halfway. But anyway, I want to thank you very much for watching. I hope you had fun, and I also hope to see you again next time. Take care. Bye-bye.